What if you could take a step back and look at the world? Explore the line between certainty and doubt. You are listening to the Illumination Hour with your host, Ellen Stallone. Hey everyone, welcome back to another episode of the Illumination Hour with me, Ellen. I hope you're all having a great week so far. Here in New Hampshire, we're getting probably about 6 inches of snow today, and it looks like more is on the way. But even though I am not a fan of cold weather, I do love it when it snows. It just turns the whole scenery into this beautiful, pure blanket, like the earth is renewing itself. It's really fascinating to watch, and even though winter is not my favorite season, it does mean that spring is on its way. So that's great. But I didn't come here to talk to you about the weather today. I wanted to talk to you about 3D printing because this is one of the new emerging markets. Well, it's not entirely new. It's actually been around longer than most people would realize. But it has become popularized over the past few years. And I want to have a discussion with you today about what 3D printing is. And, of course, what it is not. Because some people seem to think that 3D printing is a solution to all of our manufacturing problems, and I'm going to explain why that's not entirely true. But 3D printing does have a vast variety of uses and applications, and it's really fascinating to get into the science and the details of it. But first, I want to discuss the history of 3D printing. Like I said, it's been around longer than most people realize. 3D printing is a type of manufacturing called additive manufacturing. And it's not the only kind, but it is one of the main kinds. Additive manufacturing basically means that you're building up the material, whereas subtractive manufacturing is taking away from the material, like when you are routering or laser cutting something. And that's what separates 3D printing from those other technologies, is that it builds on itself. So additive manufacturing is a way to synthesize objects where successive layers of material are formed under computer control to create an object. Objects can be of almost any shape or geometry, which makes the 3D printers so versatile. They can create objects that never before have been able to be manufactured. And these are produced using digital model data from a 3D model or another electronic data source, such as additive manufacturing file or an STL file. Early additive manufacturing equipment and materials were developed in the 1980s, so that was over 30 years ago. In 1981, Hideo Kodama of Nagoya Municipal Industrial Research Institute invented 2AM, or additive manufacturing fabrication methods, of a three-dimensional plastic model with photo-hardening polymer. So that is different than the filament that you would expect to come out of a 3D printer. Photo-hardening polymer is basically like a liquid resin that is squirted in a very thin layer onto a surface, and then a UV light passes over it and it cures it. So it, in effect, turns from a liquid to a solid. Which is surprising to me because I tend to think that photo-hardening polymers, that technology seems more advanced than fused deposition modeling, which is what we typically think of. That's where the filament comes out of the heated head on the 3D printer, and it's actually a piece of plastic that gets melted and then squirted onto a surface. But of course, I was wrong here. Photo-hardening polymer is actually the older of the technologies. So, in photo-hardening polymers, like I explained, the UV exposure area is controlled by a mask pattern, or the scanning fiber transmitter. In 1984, Oliver DeWitt and Jean-Claude André filed their patent for the stereolithography process, which is now known as SLA. So this is a form of 3D printing technology used for creating models, prototypes, patterns, and production parts in a layer-by-layer fashion using photopolymerization, a process by which light causes chains of molecules to link together, forming polymers. So that is how the resin turns from liquid to a solid, because as the light reacts with the molecules, they link together to form really long chains of molecules, which are known as polymers. So these polymers then make up the body of the three-dimensional solid. The application of French inventors were abandoned by the French General Electric Company, and the claimed reason was for lack of business perspective. Boy, did they turn out to be wrong. There are so many applications for this now, and such a huge business perspective. But of course, they couldn't see that far into the future. In 1984, Chuck Hull of 3D Systems Corporation developed a prototype system based on a process known as stereolithography, in which layers are added by curing photopolymers with ultraviolet light lasers. So Hull's contribution to this history of 3D printing technology is the design of the STL file format, which is widely accepted by 3D printing software, as well as the digital slicing and infill strategies common to many processes today. So when you're designing a 3D object on your computer, whether you're using SketchUp or AutoCAD or any of those other 3D design software programs, most of them use STL files, and as you're designing them, you can view your file layer by layer. So however thin the 3D printer can print, that is how thin you can look at these layers. And they're usually only a fraction of a millimeter thick. So these are very thin layers, if you can imagine what a fraction of a millimeter looks like. So now that we've gone over a brief history of 3D printing, we know that it's been around for over 30 years and that there is more than one way to 3D print something. And there's all sorts of machines out there. They're made for printing with polymers or with plastic filament. Some of them can even be customized to print with things like chocolate or with metal. One of the best aspects of 3D printing that I want to discuss is the fact that when you go online and try to find these STL files, if you're not designing your own, there's a host of websites where you can download files for free. So it's amazing because if you have a 3D printer, you can actually go online and basically download an object. Obviously, you have to print it, but the implications of this are astonishing. Anybody in the world can design an object and put it online, and then it can be printed by almost anyone. And this is the beautiful thing about open source software. You can share everything with everyone. As we'll get into later, this has sometimes led to negative effects just because there are certain objects that governments around the world would like to control, and that has taken away from some of the freedom that people have gained with 3D printing. But nonetheless, it is a wonderful technology where people can share objects around the world, not just written words or videos or songs or copyrighted information. These are physical objects. They're just in the form of a computer file. And once you put them through your machine, they become objects. So, very fascinating. It's one of my favorite things about 3D printing. If you're looking for 3D printable files and designs, there are all sorts of websites that you can look to where you don't have to purchase these files. That's right, this information is completely free. As long as you pay for the 3D printer and the material, you can make almost anything for free. Now, obviously, there's some very complicated or rare objects that may cost money to purchase the file, but if you purchase the file and then share it online, then it just so happens to be free for everyone else. But there are a lot of good websites for this. My favorite one is Thingiverse, but there's also TurboSquid, Archive3D, CG Trader. If you just search online for free 3D files, you can find links to websites that have a list of 34 best sites for free STL files and 3D printer files. And you can get as creative as you want with this. I mean, some of these sites even allow you to edit the 3D file after you download it. Also, some of the 3D file softwares that I mentioned earlier, such as SketchUp, they are free to download. There are plenty of better softwares that you can actually purchase, but you would be surprised at the capabilities of some of these softwares. I've tried using them, and I'm not a very good designer yet because I haven't had much practice, but it's very easy and intuitive to just go on there and start creating. It's like sculpting, except on your laptop. So let's get into some of the practical applications of 3D printers. What are the practical applications, and what are the claims that are too far-reaching? Well, on the Wikipedia page about 3D printing, there is a quote here from futurologist Jeremy Rifkin, who claimed that 3D printing or additive manufacturing signals the beginning of a third industrial revolution, succeeding the production line assembly that dominated manufacturing starting in the late 19th century. Well, I agree in some form with Jeremy Rifkin that 3D printing signals the beginning of a third industrial revolution, but I don't think that we are going to be living without production line assembly anytime soon. For one thing, 3D printing is not a solution for the masses. They're not widely available, and even if they were, they are very slow comparatively at producing goods. So let's just say you need a bottle for something. You want to create your own plastic bottle. You could go to the store and buy one for $1 or $2, or you could spend the same amount of money on material and probably 3 or 4 hours waiting for it. What if you needed 5 bottles? Are you going to be waiting 20 hours for those bottles? Or would it be more effective just to go to the store and buy them from a company that has mass manufactured them? So they're very good on small-scale production, but not on larger scales. It just turns out to be impractical. Another problem with this is that some of the cheaper hobbyist machines are not very good at consistency. If you ask them to print out those 5 bottles, each one of them might end up looking slightly different or slightly warped in some way. They would be a little imperfect. Now, if you got an expensive machine, a really good one that had an enclosed system, then you will have a far better chance at getting a higher quality product. But are you going to spend, like $20,000 on a good machine just so that you can print out little trinkets around the house? Probably not. So 3D printing is not viable for common goods that need to be manufactured in mass. Let's talk about now what 3D printing is good for, what it's great for, actually. A lot of companies are saving millions of dollars now because they do have 3D printers that have amazing capabilities. First of all, as I mentioned, 3D printers are capable of producing geometries that traditional manufacturing couldn't even touch or get close to. It's good at mass customization. Companies have created services where consumers can customize objects using simplified web-based customization software and order the resulting items as 3D printed unique objects. This now allows consumers to create custom cases for their mobile phones or custom sculptures for display. It's also great for rapid manufacturing and prototyping. Now, this is where the business aspect of 3D printing comes in, because if you're a manufacturing firm and you're trying to design something, you don't want to have to go through the retooling process and spend, thousands or even millions of dollars reconfiguring your production line just to produce something that has a flaw in it and then scramble to repair that after the fact. With 3D printing, you can quickly and cheaply design an object and then print it out and see if it actually works for your needs. Advances in this technology have introduced materials that are appropriate for final manufacture, which has in turn introduced the possibility of directly manufacturing finished components. One example of this that I can think of is Boeing, the aircraft company. Boeing has actually been producing and using 3D printed parts on their aircraft. Not only does it lighten the weight of the aircraft, it is also much cheaper, and some of these 3D printing materials are very strong and heat tolerant. So, great application there. There are also many medical applications for 3D printing, as there are some materials that can be printed that are biocompatible. And actually, I did some research into this quite a while ago. I was doing a research paper and I was writing about biocompatibility, bioartificial organs, and I stumbled upon this gem. It's called the Kenzen method, which is a method of bio-3D printing. On scifusebio.com, this is where I found the information I was looking for. It says that they provide the leading-edge platform of three-dimensional organ regeneration using the revolutionary Bio-3D printer, Regenova. Regenova is a novel robotic system that facilitates the fabrication of three-dimensional cellular structures by placing cellular spheroids in fine needle arrays, which this is what the Kenzen method is. So in the first step, the spheroids are prepared, and the spheroids are actually cellular aggregates with single or mixed cell types. So it's basically just a clump of a bunch of cells. The second step is the 3D printing with the Kenzen method, which is where these spheroids are taken and they're assembled as a three-dimensional shape on this array of needles. So if you can imagine, there's a bunch of needles sticking up, and these spheroids are put onto the needles like kebabs. Then, once that's done, the third step is to let them mature. So the 3D printed tissue is cultured in a bioreactor to promote self-organization of the cells until the tissue presents the desired function and strength. So no longer are the spheroids little balls on this kebab stick. They have now formed and grown together into a viable piece of tissue. And it's amazing what you can do with this. You can create new pieces of skin for burn victims. You can produce new pieces of trachea for people who have holes in their trachea. So that's a really amazing medical application. There are also interesting things you can do with 3D printers and medicine. In 2012, Professor Leroy Cronin of Glasgow University proposed in a TED Talk that it may be possible to use chemical links to print medicine, which has actually been done. There is a pill for the treatment of epilepsy which has been 3D printed, and the pill it produces is porous and it's easily digestible, so it delivers medication to your system much faster. Similarly, 3D printing has been considered as a method of implanting stem cells capable of generating new tissue and organs in living humans. With their ability to transform into any other kind of cell in the human body, stem cells offer huge potential in 3D bioprinting. A printing based on fused filament fabrication approach has been already implemented for the creation of microstructures having an internal 3D microstructure geometry. These objects can be produced without any sacrificial structures or additional support material, just by precisely tuning the nozzle heating, fan cooling, and translation velocity parameters. The manufactured microporous structures out of polylactic acid, or PLA, can have fully controllable porosity. Such scaffolds could serve as biomedical templates for cell culturing, as well as biodegradable implants for tissue engineering. So obviously there is a bright future in medicine for 3D printing. With this technology, it could become much easier sometime in the near future to repair our bodies. And indeed, there are even more medical applications beyond the ones that I just described. In fact, it's possible to custom make implants for people or bone replacements. The way this is done is a CAT scan or MRI can be used to create 3D models of the organ or bone that needs to be replaced, and then it can be 3D printed to make sure that the design is correct, and then actually manufactured, or in some cases, using the right material, of course that's biocompatible, you can actually implant the 3D printed part itself. Imagine how much cheaper it's going to be for people to get artificial limbs now. Already people are getting 3D printed prosthetics, and they're cheaper and more customizable, and you can actually interlay electrical wires into them so that if you connect it to the person's nervous system, they can actually control their limbs. This used to be a dream for, people who had thousands and millions of dollars to spend on these prosthetics, but now they're so much more affordable. 3D printing has been used to print patient-specific implant and device for medical use. Successful operations include a titanium pelvis implanted into a British patient, titanium lower jaw transplanted into a Belgian patient, and a plastic tracheal splint for an American infant. The hearing aid and dental industries are expected to be the biggest areas of future development using the custom 3D printing technology. Imagine how great it's going to be for them. All they have to do is scan somebody's mouth, and from that they can create a full set of dentures or an exact replica of their teeth. Also, in the hearing aid industry, now people can actually get custom-fitting hearing aids. I wouldn't mind having a custom-fit headphone. Research is also being conducted on methods to bioprint replacements for lost tissue due to arthritis and cancer. This technology as well can now be used to make exact replicas of organs. Besides medicine, there's all sorts of industrial applications, like I talked about, rapid prototyping. One aspect of the industry that has been using 3D printing in a unique way is the clothing and apparel industry. Fashion designers of all sorts are experimenting with 3D printed bikinis, shoes, and dresses. In commercial production, Nike is using 3D printing to prototype and manufacture football shoes, and New Balance is 3D manufacturing custom-fit shoes for athletes. 3D printing has come to the point where companies are printing consumer-grade eyewear with on-demand custom fit and styling. although you can't print the lenses, obviously. But on-demand customization of glasses is possible with rapid prototyping. However, comment has been made in academic circles as to the potential limitation of the human acceptance of such mass-customized apparel items due to the potential reduction of brand value communication. Well, I don't know about you, but personally, I don't subscribe to brands. I don't worship brands as a god of some kind. I just think it's ridiculous that the idea of brand loyalty, unless it's a really substantially unique and virtuous brand. But when it comes to clothing, I don't really care what it is, as long as it fits me and looks nice. And that's what it sounds like people are also deciding to create with this 3D printing customizable technology. We don't need brands. We just need good quality products like these customizable glasses. One of the coolest things that I've discovered so far is that 3D printers actually have space applications. The Zero-G printer, the first 3D printer designed to operate in zero gravity, was built under a joint partnership between NASA Marshall Space Flight Center and Made in Space Incorporated. In September of 2014, SpaceX delivered the zero-gravity 3D printer to the International Space Station. On December 19, 2014, NASA emailed CAD drawings for a socket wrench to astronauts aboard the ISS, who then printed the tools using its 3D printer.
This is Mission Control Houston. Let's go down now to the Marshall Space Flight Center in Huntsville, Alabama, and talk with Lori Meggs. Lori, typically we wouldn't be talking about a printer heading up to the space station, but we hear that this one may be a little bit different and special.
That's right, Josh. It's not your average printer. This is a 3D printer that could be used on space station where NASA astronauts might not have to wait on resupply spacecraft to get their supplies. They may be actually able to build something right there. Joining me now is Nikki Werkheiser, and she is the 3D print project manager here at Marshall. Nikki, first of all, tell us what 3D printing is all about.
Hi, Lori. Happy to. Thank you for having me. 3D printing, a 3D printer will extrude plastic, metals, or other materials to build layer on top of layer to create a three-dimensional object. So you might be able to print all sorts of tools, spare parts, things like that.
So it kind of sounds like the Star Trek replicator, right?
Absolutely. We get that a lot, and it is the first step toward that.
Tell us how it all works.
Okay, the 3D printer that we're going to fly in space station will actually be the first ever 3D printer in space. There are tons of printers many people have heard about on the ground. As a matter of fact, my 9 and 11-year-old daughters are asking for one for Christmas. And they have them at Staples and places like that, and you can create all kinds of things with them. But the one that we're looking at for microgravity, of course, we want to build space parts. So the design optimization is very important. As we all know, in space, you have to wait for, as you mentioned, the resupply ships if you need a spare part, or you have to fly a lot of spares up, which take considerable mass and which cost money. Also, things break, and things do actually get lost. We've been on space station for quite a while, and things get sucked into corners and crevices.
No.
Yes, it happens. And on top of that, there are unique type of things that we could do if we had a capability to build in space. For example, CubeSats. Many people have heard about these small CubeSats, and with the onset of nanosat technologies that we have, these are used for all sorts of things in academia, commercial, and you actually can deploy them from the space station. If we were able to print these on orbit, the crew could assemble them and deploy them from station. You can do all sorts of unique structures and just an abundance of different types of experiments.
So this one was built here at Marshall?
Yeah, this one was printed here, and this is just kind of the case of one. It's got some electronics that go inside, and you deploy from station.
So how long does it take to build something like that?
Something like this would actually only probably take an hour, hour and a half. And then you also have things like this. It looks pretty non-assuming. It looks pretty simple. You could print this probably in 15 to 20 minutes. We would just upload a CAD drawing to the printer on station. But what this is actually is MSG, an extraction tool that they did not have on orbit. And actually MSG was down for around 6 months waiting on a resupply ship to bring this up. This is something with the 3D printer capability that we could have actually printed out on orbit within 30, 45 minutes, able to go.
Wow, what else do we see here?
We've got some other just fun things. Of course, people think of crew tools and wrenches. We've got a metal one here too, and we're starting with plastics for this first printer, but we will be moving to metals and other types of materials. We've got things like, you can imagine, different size sample containers. You can also do interactive.
Oh,
sorry about that. That wouldn't happen in space. It would float away. So you have interactive parts like this that can move. You can do complex parts as well with unique structures.
So tell us about the unit that is actually going to station.
So we're working with the company Made in Space. They're actually located at Ames Research Center, and the project is led here out of Marshall Space Flight Center. It's a really good interaction between this commercial company, whose business model is to create a commercial additive manufacturing 3D printing facility on space station. This is the first step. It is a technology demonstration. It will operate inside the microgravity science glove box. And NASA has been providing the discipline expertise and the expertise in terms of taking a printer that you would use on the ground, which Made in Space are absolute experts on that, as well as designing for space, and making sure that we can verify that for microgravity, the physics of microgravity, as well as the safety and operational constraints in the controlled environment of space station.
And this is also critical, being able to replace parts like this on orbit for future long duration.
Absolutely. The big thing about this is for space station even, it will decrease risk, decrease cost, and increase efficiency. But for longer term missions, for space exploration, this is absolutely a critical technology.
And talk about the ones that we have here on Earth. Will this technology make them better?
Absolutely. There's a lot of applications. We talked to several of our industry partners, as well as academia, even international partners on the ground here. This is an area that has exploded in the last few years. It's been being used in an abundance. So the lessons learned from the microgravity application could actually apply to things on the Earth, especially when you think of things such as maybe the Army. Maybe you have folks out in the field in a remote area, and they have the same type of problems we have in space. Things break and you're remote. You can also think of things like submarines or even just remote regions. Also commercial growth. So in this smaller size and form and function that you get from the printer, you could absolutely apply that to Earth applications.
So we've seen the video of the printer and work with that, but how big is this unit?
So this is kind of cool, and I don't know if you can see it here, but this is actually, we printed a model of the 3D printer. This first printer will be a technology demonstration, so it's a little smaller because we fit it inside of the microgravity science glove box on space station. So the crew will actually put their hands inside of the glove box to operate the experiment. We're getting a lot of materials data, and ultimately what this will demonstrate is that the objects that we print in space are equitable quality to those that we print on the ground, that there are no difference in the way that the printing takes place in the physics and the material quality. Made in Space has already done a series of parabolic flights on the KC-135, affectionately known as the Vomit Comet, and they've had excellent results. Everything has shown that it is equitable to Earth, but you get the short spurts of microgravity, and we want to be able to generate full products on orbit.
I'm sure astronauts are excited about this, so
yes.
Tell me when we'll see this on station.
And we will see this next fall. We'll be launching on SpaceX 5, and we're actually working with the astronaut office now. We already have a set of tools and things that they've picked out and said, hey, can you provide this for us? And we're working toward that now.
Very exciting stuff. Can't wait to see it. I'm maybe building something a little bit later on today.
Yeah, absolutely. We're having a lot of fun with this. Thank you, Lori.
Nikki, so much.
Applications for space offer the ability to print parts or tools on site, as opposed to using rockets to bring along pre-manufactured items for space missions to human colonies on the Moon, Mars, or elsewhere. The European Space Agency plans to deliver its new portable onboard 3D printer to the International Space Station by June 2015, making it the second 3D printer in space. Furthermore, the Sinterhab project is researching a lunar base constructed by 3D printing using lunar regolith as a base material. Instead of adding a binding agent to the regolith, researchers are experimenting with microwave sintering to create blocks from the raw material. Similar researches and projects like this could allow faster construction for lower cost, and has been investigated for construction of off-Earth habitats. Now that's pretty fascinating, and I'm pretty sure that right now, and even within my lifetime, terraforming is not going to be economically feasible. That's not to say that there isn't going to be a moon base or a base on Mars. There very well could be. But the idea of terraforming and actually having hundreds of people live in outer space, that seems far too expensive and probably not feasible, at least now. But the whole idea of sending 3D printers into space is a great idea because, like the example I just talked about, if the astronauts on the International Space Station need a tool of some kind, it's not like they can go out to the hardware store and buy it. If they have any hopes of getting it, they're going to have to wait until it's loaded onto the rocket, and then the rocket takes off and flies the 220 miles up to the space station, and then it has to be unloaded, and it's just a whole long process that could be avoided with 3D printers. Now, maybe they won't get as high quality products because they're 3D printing it, but at least they will have a temporary fix. Another great application that I've recently discovered that is actually quite useful for the future of our planet. 3D printers have environmental uses. For example, in Bahrain, large-scale 3D printing using a sandstone-like material has been used to create unique coral-shaped structures which encourage coral polyps to colonize and regenerate damaged reefs. These structures have a much more natural shape than other structures used to create artificial reefs, and, unlike concrete, are neither acidic nor alkaline. They have a neutral pH. So, with these 3D printers using this special and probably exotic material, I say exotic because it's not just PLA or some sort of plastic or polymer. It probably is a material that actually has powdered stone inside of it. And you call it exotic just because it's, abnormal. But having that and being able to repair damaged reefs is very helpful for the underwater ecosystem. Fish are dying, coral reefs are dying off. What's the big deal, right? Well, the ocean produces a vast amount of food, and actually it accounts for 50% of the oxygen that we breathe through all of the phytoplankton, kelp, and algae that live in it. Coral reefs are a refuge and a home not only for the coral, but for many species of fish and crustaceans, and also sea slugs. They're very cute. So, I think that's awesome. Speaking of exotic materials, consumer-grade 3D printing has resulted in new materials that have been developed specifically for 3D printers. For example, filament materials have been developed to imitate wood in its appearance as well as the texture. Furthermore, new technologies such as infusing carbon fiber into printable plastics allow for a stronger, lighter material. In addition to new structural materials that have been developed due to 3D printing, new technologies have allowed for patterns to be applied directly to 3D printed parts. Iron oxide-free Portland cement powder has been used to create architectural structures up to 9 feet in height. There are all sorts of interesting specialty materials for 3D printers, besides the ones just listed. There are filaments you can purchase that have copper. You can get 3D printer filaments that have carbon fiber, ceramic, glow-in-the-dark filament, stone, high-impact polystyrene, metal filament, flexible and soft filaments, wax. There's an incredible variety out there on the market, and they can all be used for very specific tasks. One of the most famous recent stories involving 3D printing had to do with firearms. And, of course, I can't not talk about this. It's a huge topic of debate internationally. So anyway, in 2012, the US-based group Defense Distributed disclosed plans to design a working plastic gun that could be downloaded and reproduced by anyone with a 3D printer. Defense Distributed had also designed a 3D printable AR-15 type rifle lower receiver, which was capable of lasting more than 650 rounds, and a 30-round M16 magazine. The AR-15 has multiple receivers, both upper and lower, but the legally controlled part is the one that is serialized, the lower in the AR-15's case. Soon after, Defense Distributed succeeded in designing the first working blueprints to produce a plastic gun with a 3D printer in May of 2013. The United States Department of State demanded that they remove the instructions from their website.
I'm going to introduce you to Cody Wilson. He has been called one of the most dangerous men on Earth, and he is the founder of Defense Distributed, the nonprofit group that launched the Wiki Weapon Project initiative to raise $20,000 to design and release a plastic gun that anyone can print from their own computer. It would be distributed for free. It would allow anyone who wanted a gun to get one just by hitting print. I will tell you that I said last week that we are going to come to a place where people are going to print guns. And people on my own staff said, not going to do that. Really? Here they are, all printed by a 3D printer. And the magazines. How are you, sir?
I'm doing well. Thank you for having me.
You can't print the whole gun because it's illegal.
That's right. That's right. It's actually legal 2 different ways under Title 18 to make undetectable firearms or weapons that would not be regulated by Title I.
Okay, but you could fire this.
I have fired that.
You have fired
That's
that.
right, yeah.
Okay.
And I've fired all these pieces as well.
You made all of this yourself? Or
The trigger group is a standard trigger group we fit in just to show that our pieces were right, our measurements were right. The white piece is the printed piece.
Now, here's what, I mean, this is both exciting and frightening because every dynamic on planet Earth changes. You know, it's frightening because Occupy Wall Street, take over the world. It's wonderful because the Holocaust wouldn't have happened. I mean, it just depends on how you decide to use them, which is meaning we have to be in control of ourselves. Because if they try to, and they will, they've stopped you from making a gun, right? You're not going to make the whole gun.
I've been disciplined from not making it, but I'm going to make it. You know, it's just a matter of following their law.
Okay. So you'll do it the right way. Is there any doubt in your mind that those who are nefarious, who have the same, you'll make anything? Why go buy and smuggle your guns through Eric Holder when you can just print them?
Well, if Eric Holder's giving away M16s for free, I'll take his M16.
Right.
But right, this does add some questions and some complexity to things. Undetectable firearms, unknown firearms in commerce, assembled out of parts that aren't registered. There are new dimensions, new folds, new moral problems.
Okay. Any way to put the genie back in the bottle?
No, I'll show you. This magazine, for example, right, was just one file 2 days ago. Now it's been downloaded over 50,000 times. You know, the internet has it. And as long as these machines keep getting better, this is no longer bannable in some traditional sense, in some progressive sense of controlling.
So in other words, they can ban it all they want, but somebody is just going to print it. And this was all just printed on a 3D printer.
That's right, an SLA from the 90s. It's an old technology was used to create that. You know, I don't have
the first time I ever saw this,
stuff.
I was in Jay Leno's garage. Oh, yeah. And he had a Stanley steamer, and he said, "Do you know what it's like to get a cog for a Stanley steamer?" And I said, "No." And he said, "Until this machine, you couldn't get it." And he showed me, and it was as big as a huge refrigerator. And he said, "You just put the broken piece in there, and it scans it, and then it just makes it."
That's right.
And I thought that was amazing. And I own that one. I mean, and that's like a little, that's just like a little one that is $2,000. These replicators, to make this, how much would the replicator cost?
Oh, a replicator making that?
Yeah.
We haven't made one on a replicator, but the volume under $50.
How did you make this
under $50.
in a 3D printer?
Yeah, we made it in an SLA 3D printer, which uses a little bit different technology.
Which is what?
This was made with a laser and a UV resin.
And that's what, that's when they come together, when the lasers hit?
Yeah, more or less. There's two different technologies, not to get too complicated, but it cures a resin, and the resin hardens very quickly. And, you're done in about 9 hours.
How much it cost you?
About $100 in materials.
And how much does the actual printer or the machine cost you?
Multiple thousands of dollars, but demand will drive prices down. It's just a matter of time and what technology the market prefers.
What is the thing that, do you have any concerns at all about this technology?
Well, we're doing this project and using this technology as a form of resistance. So it's just a critical use of the technology. Of course, we have concerns at the end of the day, right? But we see liberty under threat. We see sovereignty under threat. We must respond.
So they try to take this, they can't take this away because everything, the technology is out and everything is being mapped. And you just really do, it was shocking to me, all you really do is hit print.
That's right.
You download it and you hit print.
This is an alternative way of manufacturing things, and it really takes out almost all expert required knowledge. The model is already in software. You can download it. If you have a machine, you just tell the machine to make it, then you have it. It's that simple.
Okay, so America, here's your decision point. Your decision point is this guy a hero or a villain?
That's a good question.
What do you think you are?
I don't like the dichotomy, right? In whose conception, under what paradigm, I'm just resisting. What am I resisting? I don't know. The collectivization of manufacture, the institutionalization of the human psyche. I'm not sure. But I can tell you one thing. This is a symbol of reversibility. They can never eradicate the gun from the earth.
I'm big into whys. I know why I do everything.
Yeah.
And that's where we connect, is on why. So I don't think I buy your BS on what you just said to me on why. Well, I'm this or I'm that. I don't know. Yes, you do. Why do you do it?
I do it because I decided process isn't the way to preserve liberty. I don't believe in Romney.
What does that mean?
I don't believe in Romney versus Obama. I believe in real politics. That's a real political act, giving you a magazine, telling you that will never be taken away. That wasn't true maybe 2 weeks ago. Now it's a fact of life. It's a fact of history. That's real politics. That's radical equality. That's what I believe in.
Are you concerned at all? See, these are the debates we're going to have, America. Are you concerned at all about things like, and the gun is somewhat different because this is the great equalizer, if you will. Whoever had the gun manufacturers, whoever controls the gun manufacturers would win until this. Okay. However, just like the music industry and the movie industry, if you can copy things, then somebody who designed this, somebody who spent money and time and effort to design it, you're taking it from them. What happens to the patent?
I designed that. That was my property, and I gave it away, if we accept that conception of things. So, you're welcome. But
wait. You didn't, because you didn't. Somebody else designed.
The magazine is our design.
It's your design.
Defense Distributors' design.
Okay.
Our proprietary design. This was an old, the AR lower design has been out in the wild for years. It's a mil-spec kind of design. It's not any one person's, although Eugene Stoner is celebrated.
So would you agree that patents are important or not?
Oh, okay, down the road. Yeah, intellectual property is an interesting debate, and I fall on both sides of it. So I see an interest in preserving illegal monopolies sometimes for people to...
It's what made America America.
It makes some sense. And at the same time, I'm partial to the debate of kind of the anarchist left, which is that really these state monopolies allow undue profits.
Okay. So are you an anarchist?
I guess in a functional sense, sure, but perhaps like a principled one.
I don't know what that means.
Well, there's a guy named Michel Foucault, and I'd recommend that you read him sometime. Really, I see the battle as one of just trying to remain human. and against massive forces, anonymous forces of discipline and control that we can't really understand. I don't think there's a massive conspiracy, but I do think the self is under siege, and I think liberty itself is under siege. Human liberty, human spontaneity, the freedom to do things.
I would agree with you. But if it devolves into either chaos or totalitarianism, you've lost it all.
I think there are different visions of what totalitarianism is. It seems to me the progressives and the conservatives are both lined up against a strong state authoritarianism either way. Either that's a socialized collective vision or a more kind of police. Well, either way.
Yeah.
Both seem to me to be the authors of an increasing surveillance and police state. I don't agree with that.
Have you read much about the Articles of Confederation? And okay.
Yeah, definitely.
I mean, there is a point in liberty that even the most libertarian or close to anarchist member of our founders understood. You have to have some
state power.
You have to have some power just to hold things together. Limited as possible.
I like the argument, and I'm partial to it, and I like the founders. But I think I never want to say this time it's different. That's a kind of progressive argument, But
Cody, you are. I don't know if we are friend or foe.
Yeah.
I appreciate the debate, and I appreciate the idea that man will be free. Man will be free. Because this is not going to stop. They could put you in jail and it wouldn't matter. This isn't going to stop.
It's over. Yeah.
Thank you.
After Defense Distributed released their plans, questions were raised regarding the effects that 3D printing and widespread consumer-level CNC machining may have on gun control effectiveness. In 2014, a man from Japan became the first person in the world to be imprisoned for making 3D printed firearms. So, I am not a huge fan of guns. I think they are unnecessary lethal force. Of course, I know how to operate a firearm, and I've used them before just in target practice. And I wouldn't be opposed to using one for self-defense or for hunting, but just in general, I'm not a huge fan of them. But I think that it can only be a good thing that designs are being openly shared online, even if it is for guns. And if this is having a negative effect on gun control, then good. These items, and all items, in fact, should not be controlled by the government. That is something that individuals need to decide for themselves, whether or not they want one. And if they do, then who's to stop them from getting the blueprints online? That's not the place of controlling organizations. That is a personal decision for individuals to make. Again, that is one of the main benefits of 3D printers and 3D models, is that they are open source, and sharing is caring. So, of course, I've named here quite a few of the applications for 3D printers, and although they're not practical for everyday usage, they are becoming much more a part of education and research for younger generations. 3D printing and open source 3D printers in particular are the latest technology making inroads into the classroom. 3D printing allows students to create prototypes of items without the use of expensive tooling required in subtractive manufacturing methods. Students design and produce actual models that they can hold. Now, this is great for kids especially, because when they're learning mathematics or when they're learning anything to do with creating, they don't want to just do it out on paper and look at it that way. They want something that is tangible, because that is the best method of teaching. The classroom environment allows students to learn and employ new applications for 3D printing. RepRaps, for example, have already been used for an educational mobile robotics platform. Some authors have claimed that 3D printers offer an unprecedented revolution in STEM education. the evidence for such claims comes from both low-cost ability for rapid prototyping in the classroom by students, and also the fabrication of low-cost, high-quality scientific equipment from open hardware designs forming open-source labs. Engineering and design principles are explored as well as architectural planning. Students recreate duplicates of museum items such as fossils or historical artifacts for study in the classroom without possibly damaging sensitive collections. Other students interested in graphic designing can construct models with complex working parts easily. 3D printing gives students a new perspective with topographic maps. Science students can study cross-sections of internal organs of the body and other biological specimens. And chemistry students can explore 3D models of molecules and the relationship within chemical compounds. So, it's incredibly fascinating, it has many uses, and I would like to see what sort of innovation comes about in this industry within the next few years. Because although it's not going to replace large-scale manufacturing firms, it is a way to revolutionize manufacturing in the way that now anybody is capable of producing objects, of creating new items that before they probably did not have the materials or the access to software and machinery that could create these items. There's a bright future for 3D printing, and it's full of innovation and creativity. And those are some of the best virtues that people can hold, because creativity is really what allows us to solve problems, to come up with new solutions, to explore aspects of the world that before seemed untouchable. There's so much potential with this technology, and I hope that at some point you decide to start exploring the possibilities within 3D modeling, and maybe even print something of your own. In some areas, in some cities, there are actually public 3D printers where you can take your 3D model files and print them out. This has massive implications, of course, especially on the individual level, because now you don't just have to be a passive consumer where you have limited options as to what you can purchase or what you can find. Now you can actually be the active creator. You can be the god of your own creation. You can shape and mold the world into whatever you want, as long as it can be printed inside the platform, of course. But one of my main hopes for this, as far as society and individuals go, is that people will begin to take their life as far as what they want to see produced, what they want to see in the world, and they will create that change themselves, physically. Well, that's all I have for you this week. Thank you for listening to the Illumination Hour. If you have any questions or comments, please email me at illuminationhour@gmail.com. Have a great week, everyone. Thanks for listening. Bye. What if you could take a step back and look at the world? Explore the line between certainty and doubt. You are listening to the Illumination Hour with your host, Ellen Stallone. Hey everyone, welcome back to another episode of the Illumination Hour with me, Ellen. I hope you're all having a great week so far. Here in New Hampshire, we're getting probably about 6 inches of snow today, and it looks like more is on the way. But even though I am not a fan of cold weather, I do love it when it snows. It just turns the whole scenery into this beautiful, pure blanket, like the earth is renewing itself. It's really fascinating to watch, and even though winter's not my favorite season, it does mean that spring is on its way. So that's great. But I didn't come here to talk to you about the weather today. I wanted to talk to you about 3D printing because this is one of the new emerging markets, well, the technologies. So, in photo hardening polymers, like I explained, the UV exposure area is controlled by a mask pattern, or the scanning fiber transmitter. In 1984, Oliver DeWitt and Jean-Claude André filed their patent for the stereolithography process, which is now known as SLA. So this is a form of 3D printing technology used for creating models, prototypes, patterns, and production parts in a layer-by-layer fashion using photopolymerization, a process by which light causes chains of molecules to link together, forming polymers. So that is how the resin turns from liquid to a solid, because as the light reacts with the molecules, they link together to form really long chains of molecules, which are known as polymers. So these polymers then make up the body of the three-dimensional solid. The application of French inventors were abandoned by the French General Electric Company, and the claimed reason was for lack of business perspective. Boy, did they turn out to be wrong. There are so many applications for this now, and such a huge business perspective. But of course, they couldn't see that far into the future. In 1984, Chuck Hull of 3D Systems Corporation developed a prototype system based on a process known as stereolithography, in which layers are added by curing photopolymers with ultraviolet light lasers. So Hull's contribution to this history of 3D printing technology is the design of the STL file format, which is widely accepted by 3D printing software, as well as the digital slicing and infill strategies common to many processes today. So when you're designing a 3D object on your computer, whether you're using SketchUp or AutoCAD or any of those other 3D design software programs, most of them use STL files, and as you're designing them, you can view your file layer by layer. So however thin the 3D printer can print, that is how thin you can look at these layers. And they're usually only a fraction of a millimeter thick. So these are very thin layers, if you can imagine what a fraction of a millimeter looks like. So now that we've gone over a brief history of 3D printing, we know that it's been around for over 30 years and that there is more than one way to 3D print something. And there's all sorts of machines out there. They're made for printing with polymers or with plastic filament. Some of them can even be customized to print with things like chocolate or with metal. One of the best aspects of 3D printing that I want to discuss is the fact that when you go online and try to find these STL files, if you're not designing your own, there's a host of websites where you can download files for free. So it's amazing because if you have a 3D, it's not entirely new. It's actually been around longer than most people would realize, but it has become popularized over the past few years, and I want to have a discussion with you today about what 3D printing is, and, of course, what it is not. Because some people seem to think that 3D printing is a solution to all of our manufacturing problems, and I'm going to explain why that's not entirely true. But 3D printing does have a vast variety of uses and applications, and it's really fascinating to get into the science and the details of it. But first, I want to discuss the history of 3D printing. Like I said, it's been around longer than most people realize. 3D printing is a type of manufacturing called additive manufacturing, and it's not the only kind, but it is one of the main kinds. Additive manufacturing basically means that you're building up the material, whereas subtractive manufacturing is taking away from the material, like when you are routering or laser cutting something. And that's what separates 3D printing from those other technologies, is that it builds on itself. So additive manufacturing is a way to synthesize objects where successive layers of material are formed under computer control to create an object. Objects can be of almost any shape or geometry, which makes the 3D printers so versatile. They can create objects that never before have been able to be manufactured. And these are produced using digital model data from a 3D model or another electronic data source, such as additive manufacturing file or an STL file. Early additive manufacturing equipment and materials were developed in the 1980s, so that was over 30 years ago. In 1981, Hideo Kodama of Nagoya Municipal Industrial Research Institute invented 2AM, or additive manufacturing fabrication methods, of a three-dimensional plastic model with photo-hardening polymer. So that is different than the filament that you would expect to come out of a 3D printer. Photo-hardening polymer is basically like a liquid resin that is squirted in a very thin layer onto a surface, and then a UV light passes over it and it cures it. So it, in effect, turns from a liquid to a solid. Which is surprising to me because I tend to think that photo-hardening polymers, that technology seems more advanced than fused deposition modeling, which is what we typically think of. That's where the filament comes out of the heated head on the 3D printer, and it's actually a piece of plastic that gets melted and then squirted onto a surface. But, of course, I was wrong here. Photo-hardening polymer is actually the older